to you all. Let's begin with this. Here comes the need. What is Z bus? How we frame Z bus algorithm and all. What is the need of that? So that to go, I just go with the direct content of which will be very useful to you. Suppose, see this example. This example is having certain buses. See that left side block, bus 1, bus 2, bus 3. There are different transmission sections shown with the impedances Z1, Z2, Z3, Z4, Z5 like that. This is the actual final interconnection. How do you start building Z bus in the theoretical perspective of that, step by step, without going to the real field? We are not supposed to go to the real field of the power system. Sitting in the computer room, you can simulate, create, and get the value of Z bus of that system in step-by-step building mechanism. To understand that, there are different steps shown here. Just for us knowledge, I will just show you. See here, there are how many elements? 1, 2, 3, 4, 5 impedances are shown for 3 bus configuration and ground as a reference. How it is being done? Just observe these images. There is a connectivity of bus 1, bus 2, bus 3 and ground. J is referred here. Okay. Between J to 1, they start laying a connectivity establishment. Greenish color you can see here. This is the first activity. Then this become old activity. New activity is connecting from J to 2. You can see step by step building this. Second activity, second image. And third image is connecting bus 2 to bus 3, because 2 to 3 there is a element here. So reference to bus 1, reference to bus 2, 2 to 3 is an activity in the image number 3 here. Then 2 to 1 is connected here. You can see the greenish link which is shown here. So step number 4. Then step number 5 is 1 and 3, this last one. You can see greenish connectivity between 1 and 3. So how it is being done? The entire given power system is visualized on the drawing or on the space. Step by step connectivity is considered and create data concerned to that in the form of a matrix with the relevant theoretical proofs. So I have shown this problem just to show you how many steps are needed here. Each element you need to connect one at a time. After having connected one, its mathematical reflection into a matrix form should be formed. When it is the first time, it is a 1 cross 1 element, because first time you are drawing a line. When it becomes a second activity, old activity which was already done, second activity new you are doing, dimension of your Z bus builds to 2 cross 2, 3 cross 3. Then additional 3 cross 3, 3 cross 3. You may ask me, why 3 cross 3, 3 cross 3 at the end? Again, there comes a technique. What is that activity you are creating? Is it a branch? Is it a link? We need to understand. If it is a branch, new row, new column created. If it is a link, no new row, new column is created in the memory. That is the mathematical requirement of Zbuild algorithm. In that perspective, simple one problem I have just shown you. How is that work takes place in the reality? This we will understand and will go to mathematical structure of this. How it is mathematically proved. What is that row number, column number, value by, all we need to know. For that, I revisit this once again. Reference to 1, I initiate first activity. First time I am adding elements contribute to Z bus by 1 cross 1 value. Then reference to bus 2, green you can see here. Second activity, the dimension of the Z bus increases because 1 is first time access, 2 is first time access. So element dimension increases. Then third bus is visualized. Between 2 and 3 you are connecting a line. This is a branch because 3 is new, 2 is old, already addressed. Like that, we have the theoretical requirement of that. Then 2 to 1. 2 was old, 1 was old. It is called link. Link will not create dimension increase here. You can see 3 cross 3 was in the previous diagram. Same 3 cross 3 matrix will remain, but values of the elements become different because of the addition of this 2 to 1 value in this case. Similarly, when I add 3 to 1, 3 was already addressed here, 1 is already addressed here, no more new number entry. Hence, dimension of Z bus remain 3 cross 3, but values of all the concerned elements become refreshed. This way, this activity need understanding of when is that extra row and column get added, when is that extra row and column did not get added, we need to understand. For that, I just took this example. Then I take you to the reality. Yeah. Let's take a simple concept. Let us consider a power system. There are so many buses in the system. Buses are marked here. You can see this rectangular representation. Partial network. How many buses were there? 0, a reference bus. 1, 2, 3, I, K, L, M, like that. So many buses are represented in the system. This is an existing system. You can imagine KLE-IT is a power system. All the departments are terminals. Let office be reference. Office is called reference bus. All other departments are like 1, 2, 3, 4, 5, KL, MN, like that. Now this is called partial network, which is already existing. Now there comes a new department established in the campus. Let's say Q. You can see here. Q is a new department established. So P to Q, there comes a transmission line drawn. To power up this department Q, I draw a line to get the electrical connectivity. This transmission section which is added is what? Is it a branch? Is it a link? We need to understand. It may be like this way. Power supply to this new department may be given from P department to Q department, or office, that is reference to Q department. I can connect. However, it requires a connectivity. It can be either neighbor department to the new department, or from the office to new department, what I want. So this way, I can power this new department to the old system. What I configure here is, I had a old system which is called partial network. To the partial network, when I interface new bus can have a connectivity with the old buses, either from the reference as shown in the last diagram, like this, or from the one of the neighbor existing buses other than reference. There could be a transmission section. This kind of extension of service to the new bus is called adding a branch. When a new branch becomes member of the old system, it creates one row, one column extra in the Z bus what it was for the previous part. This network had a Z bus. To this Z bus, new member Q is added. Addition of a new bus will create one row, one column extra. That you can see in the matrix form. All the voltages of the buses, V1, V2, V3, VP, VM, all are here. You can see this. Then all the injections of current at bus 1, 2, 3, where I1, I2, I3, IP, IM, like this. Now, when Q become new member, when Q become a new member, you can see there could be a measure of VQ like V1, V2, V3, V4, VM. I can measure voltage at Q also. That is VQ, newly added representation, which is superposition of voltage read here. When there is an injection of current in the first bus, there is a notice of voltage at Q. There is an injection of current at the bus 2, notice of voltage at bus Q. Like that, VQ is Z Q1 I1, Z Q2 I2, Z QP IP. Like that, it will have set of impedances like this, and a diagonal Z QQ with the injection of current at Q itself. What do you mean by this? My interest is, suppose I have a power system. given power system. New transmission line is erected. How to modify the existing system Z bus to the revised one? I should know. Suppose there occur a fault. One of the transmission lines open circuited. Line is open. I have to eliminate that. When I want to eliminate, what is that reflection of that elimination into the Z bus for my further computation? I must know. For that, this is very necessary. Modification of bus matrix for the suitability is very necessary. First, we will try to build, later we will try to eliminate if required. Then, for addition of a element, addition of a new branch or a new buses to a system, it creates a new row of data, new column of data, and one diagonal element here. Whatever the ZQ1 I have, same as Z1Q here. 1Q is same as this row. If I transpose, it become here. Like this. Q1, Q2 become 1Q, 2Q, 3Q, like this. Last element is Z, QQ, then IQ. So, the work in this first part is when partial network is interfaced with a new bus, either from the existing bus or from the reference bus, there is an addition of one row, one column to the existing matrix of the system. It was M cross M or old, M buses were there. It was M cross M, you can see this. This was the original matrix. To this matrix, red line, a row, a column is added. This dimension of this system is increased by one row, one column on addition of one bus, that is Q. Either to the reference to Q or existing P to Q or any number to Q. That will build one row, one column. Now task is, what is the value of ZQ1, ZQ2 we need to do. This is one concept. We call it as addition of a branch. Branch is added to the partial network if the bus added to the system is absolutely new. Q is not at all the member of old system. Q is not the member here. Q is outsider. Then Q, when I interface, Q will create one row, one column entries in the matrix. That kind of interface we call as addition of a branch. The addition of a branch can be a two-way, either from the reference like this or from the existing one of the bus to new position. So reference to Q when I add, this is called type 1 modification. And any number of buses to which is other than reference to new bus is type 2 modification. We need to understand. When I add a branch can be type 1 by structure, type 2 by structure. When type 1, it has its own derivation. Type 2, it has its own derivation. We need to understand. Similarly, when I add a link, see the same thing. I am trying to add a new line between department of computer science to information science, or electrical to library, or mechanical to civil. There is no new branch added here, new department added. Within the department, I am trying to add a new line here like this, or from the office to computer science, and again from the one more office to one more office computer science, new line I am drawing. Anything which will not create additional bus, but connectivity is created. This is called creating a link, adding a link. Now for this, as the Z bus, which was suppose M cross M originally, should remain M cross M. For the mathematical perspective, temporarily, this addition of a link, which is between any two numbers or from the reference to any number, you can see, from reference to any bus, which is old numbers, bus to old bus, old only. This kind of additional is called as link addition. So this will not create one row extra, one column extra in the space. But mathematically, we have to have a proof of that. We create a row, a column, and we dissolve this row and column at the end. Temporarily, we create this, we flash these values on others. Delete this row column by modifying the cell values, then this row and column disappear at the end. So this kind of modification we call as link modification. In this link, again two types. Link can be reference to existing buses or existing bus to existing bus. So type 3, type 4. So altogether I have 4 modifications. Then how it is understood then? Then it has a proof like this. Come to this structure. Suppose, look at the diagram. There is a n bus system, rectangle box you can see. There are n buses, 1, 2, 3, 4, 5, 6, 7, and there is a reference, maybe 0 or type 1 I want to mention. What is type 1? Type 1 is adding a new bus from the reference. It means like this structure. New bus is interface to the reference. This would create a row and column. Yes. What are the values of this? We try to obtain. Let's look into this. Reference is R, K is new bus. 1, 2, 3, I, J, whatever you have. K is new. Before adding K, what was the Z bus for this? You just see this rectangle. Inside this, it was Z bus old. It has some dimension, n cross n. To this, one row, one column get added. Our task is, what are all these values? We have to identify theoretically. For that, let us consider the branch which I connect from new bus K with the reference B ZB impedance. Okay. Then old Z bus undergo modification. Then I refer, let I and J be any old buses. Let R be reference bus. Let K be new bus I want to interface. These are prerequisites. Then IK be the current injected via K. ZB be the impedance of the branch. Let there be a measure of voltage Vk at bus K after interfacing. Exactly. V1 I measure at 1. Vn I measure at n. Vi I measure at I. Like that. Vk be the voltage at kth bus when Ik enter this branch with the impedance ZB. Now look at the diagram. It shows a passive linear n bus system as shown in the diagram with the impedance ZB. New branch is added from K to reference. Now what is that voltage I can measure here is, we can see when current Ik flows here, Ik into ZB due to Vk. You can see here. Vk equal to ZB into Ik. Then what is that? ZKI, ZIK. It means new bus K is introduced. It means new bus K is introduced. It should have a new row in the matrix, which were 1, 2, 3, 4, 5, n. Like n was the last number here. To the n, K is added. Row number K, column number K. Then what is the position of K1, K2, K third column, K4, that's called Ki. ZKI is same as here also, because this row is transposed here as Ik. K1 is same as 1K, K2 is same as 2K, which we have seen here. Can you see? Here. Q1 is same as 1Q, Q2 is same as 2Q. What is this value individually? I am trying to convey. It means ZKI and ZIK are 0 because it is connected to reference. For all the branches, it is 0. Only you are connecting to reference. Then ZKK, most diagonal itself is only ZB. The modification for the old Z bus is, if at all you are trying to add any new bus to the old bus, new bus connected to reference bus via impedance, impedance value will be positioned at the diagonal of that. Whole row is 0, whole column is 0, only diagonal is impedance of the new branch. That is because this will not have any reflection on this. This is interface only with the reference. It can measure only Vk as a voltage due to ZB and Ik. Then I have all zeros here, all zki and zik's are 0, only zkk, k cross k. This is called diagonal. In this case, it was QQ. You can see QQ, ZQQ. And now I am calling it as KK, which is the only value ZB. Rest all are 0 when type 1 is considered. Type 1 is mod. Adding a new bus to the reference bus. All the row elements are 0, column elements are 0. Diagonal is the only element building the voltage at Q. That's what is said here. Vk is red only because of this. Vk is red because of this Ik, nothing else of this. Hence, all these will be zeros. Then your old Z bus of, say it was 3 cross 3, now it become 4 cross 4. This is the modification we need to see type 1. So it come very necessary. It is not that type 1 only should come, type 2 only should come, or any type modification will occur in the process of our Zbuild algorithm. If at all new bus is introduced to the reference, and this would be the modification, means only diagonally it is protruding, diagonally it move next, all these row and column elements are 0. This is one type. Type 2 may be like this way. Type 2 is what? Let's look at the passive partial network. Let there be n elements, n buses. Let there be a bus k. K is connected to j. I am not adding line between k and reference. K to reference I have added in the type 1 modification. Now this branch I will connect to j. I will not connect it to reference. I will remove this. I connect it from j. J to k I connect. That is nothing but this way. J, K, P to Q. How I connect it? P is old, Q is new. Like that. J is old, K is new. I would like to connect. Can you see here? J is old, J to K. I connect a line with the ZB impedance. Then I measure voltage at K, which is Vk from the reference. From the reference bus, I can read voltage of the bus K is Vk. Now I have at bus I, J, there is a current of Ij going. From the K bus, Ik is going. Then Ik plus Ij together enters this system. With this, I can write what is that terminal description of this representation. Type 2 modification is known as adding a new bus to the existing bus, which will again create a row and column because it is a branch. Whenever you introduce a new bus number to the existing system, that is going to create a row and column. How it is going to create is type 1, not type 2. If it is type 1, all the row elements, column elements are 0. Only diagonal value is by the value of the impedance of the line you are connecting. If it is type 2, we are connecting that element ZB to any of the old number of the buses, not the reference. This would be the structure of that. Then J to K, you are adding a branch. There could be a Ik ampere, Ij ampere, together rush into the Vj. Then I have, what is the voltage of Vk now? Voltage Vk is now measured as relative. What is that? Vj plus Zb into Ik. See, when the current rushing here, Zb into Ik is the potential across this. If I add this potential with the Vj plus Zb into Ik stand as Vk, which I can measure from reference. Why I am doing all these things? Because I need not go to real field of the power system. Sitting in the computer center, I can simulate entire work without going outside. That's why fundamentals must be very clear. Bus J is where? I don't know. Bus K is where physically? I do not know. But I know connectivity by drawing this way. By drawing this, I will be knowing if I know the voltage of Vj, if I know the Zb and Ij, Ik value, I can get Vk. My computers will help me to solve this problem. Therefore, I write Vk relative as Vj, which is the voltage of the bus J, plus ZB into IK. Now I know what is Vj in terms of superposition of voltage and all. Yes, Vj is, look into this, Vj is, you can look here, Zj1 I1, Zj2 I2, dot like this. Can you see? Zjn In, Zb into Ik plus Zjj Ij plus Ik. It means I come to this. What is this equation? I'll take you back. Vj is the voltage read at bus J, like V1, V2, V3, like that. Without this, what is that? Vj due to bus 1 here. V1 is due to Z11 I1. V1 plus Z12 I2 plus Z13 I3. Likewise, any voltage at any bus, I go back still here. Any voltage at say bus number P, Vp is what? Zp1 I1 plus Zp2 I2, Zpp Ip, Zpm Im. It is a superposition of voltage built at bus P due to bus 1 current, due to bus 2 current, due to bus P current, so called. How many buses are there in the system? Whenever there is a current in those respective buses, that will create a potential at your pth bus. Superposition of this results bus voltage Vp. If I solve this equation, what I'll get? Vp equal to Zp1 into I1 plus Zp2 into Ip. Yes or no? Same thing. So here I am trying to do the same thing. Vj, what is Vj? Vj is Zj1 I1. Instead of PQ, I have J and 1. And Z second element, Zj2 I2. So called Zjj Ij, Zjn In originally. Now there is a branch added here which is causing a K current to go inside. Then this K current become Zjj Ij plus Ik. Then Zb into Ik extra. Originally, this Zjj should have Ij alone when Ik is not connected to this. Similarly, Zb Ik won't be there. When I connect a line to K to J, Ik is the extra current rushing to this. Then Jj will have Ij plus Ik. Then extra term Zb into Ik. This is the potential of kth voltage. Nothing but Vj I am adding. Vj plus Zb Ik. Why I am doing this? If I know the previous voltage where I am connecting, whose voltage with this drop become my next voltage? Very easy to understand. I should know Vg, like your transmission system. Receiving end if you know, sending end profile can be easily obtained. Like that, jth bus voltage if you know, and kth bus voltage is jth bus voltage plus this potential. I'll get K. The same thing I am doing. Vk equal to what? Vj plus Zb into Ik. What is Vj originally? A string. It is a string of superposition of potentials due to bus 1, bus 2, bus 3, bus K, etc. Then I will rearrange this. On rearranging, you can see J1 into I1, J2 into I2, Jj into Ij, correct? Jj into Ij. This Jj into Ik is separated. So, Jj into Ij, Jn into In plus, here is the Zb into Ik, Zjj into Ik. I add Zjj, Zb in a single bracket outside K. By doing this, I measured voltage of a new bus K as row elements Zj1, Zj2, Zjj, Zjn, and the diagonal element is Jj plus Zb. You can see here. This was the old bus what I had earlier. The kth row, new column, new diagonal, what I wanted to evaluate were readily available here. What is Zj1? Available in Vj equation. What is Zj2? available in Vijay equation. Everything is available. All these Z values are available in the Vijay equation. It means where you connect, copy the elements. Row number J, copy paste to row number K. Jth row, ZJ1, ZJ2, ZJK, whatever we had. Copy paste, copy paste, copy paste in this row. Then throw this on the column, transpose of this. Then the diagonal is what? The last element, ZJJ plus Z. That's the end. What you did now? It was the old bus. From the old bus, where you connected this K to J, row number J, elements you copy paste. Reflect here. Diagonal is JJ plus ZB. That's all. It got one row extra, one column extra. Type 2 modification you have done. Type 2 modification and type 1 modification are just different by this way. When you connect a new bus to the reference, all these values are 0 because you are connecting from reference. Only diagonal is ZB at that time. When you connect a new bus to the one of the existing bus other than reference, to which bus you are connecting, that entire row element you copy paste. I am connecting to J. Jth row is copy paste here. That's all. Shift it to column, transpose. Then get this diagonal JJ plus new value ZB, what you connect. Very simple. By this way, branch modification you have brought. So what has been done? I'll just go back and see. When I want to add a new bus to the existing bus, Q is interface with the new, P old bus. You can see VK, where I am seeing it is VQ, no doubt. ZQ1, ZQ2 were the elements. Nothing but these were the used elements. These are the values of P, ZP1, ZP2. These are the one copy paste, copy paste, copy paste, copy paste. Because bus number Q is interface with the P. Row number P, wherever we have here elements, you copy paste, you reflect. Then ZQQ. ZQQ is ZPQ, P to Q plus the diagonal value what you are adding. It's very simple. That will create voltage of VQ. What you can see. VQ is superposition of voltage ZQ1 into I1 plus ZQ2 into I2. What the same I am just mentioning. Same thing. From instead of P, I have J here. That's all. So one row is extra, column is extra. So this is called modification of Z bus for addition of a branch from old bus to new bus. No doubt it will create one row, one column extra. So this kind of modification will build one row, one column extra. We call it as branch modification. It may not be the case in the real time, which we were seeing in the earlier diagram. This kind of modification may happen. Any reference to neighbor existing system, one more transmission line can be drawn. Or between the department, there could be another transmission line drawn. This is called link modification. Link modification will not have any one row extra, one column extra. This is true because is it creating a new bus in the system? Can you see here? Any voltage you can see, new voltage, 0. You are not reading any voltage because there is no additional number added to the system. Existing system is working with the transmission connectivity. Therefore, there is no increase of one row, one column here. But for the theoretical work on the paper, we consider link as a branch. Create one row, one column with 0 value here. 0 means what? No value. It's nothing to delete it. Before you delete, reflect value of this on the cells. Reflect, reflect, reflect. Delete this column, draw. That's what we do. So that's how link modification to the existing Z bus will not create one row, one column, but that will modify the cells. This I must know. To do this, I take up type 3 activity. Look at this. What is type 3 activity? For that, you observe there is a given power system with a partial network. there are so many buses, 1, 2, 3, 4, 5, K, N, and reference. I will try to add new branch between office to computer science or office to old bus like this. This will not create J extra because J is already a member of the system. This is called link. Link is a addition of a element in the existing system which will not create new entry to the Z bus. That's what we have to understand very clearly. Link is an activity of addition of a new section which will not create any bus into the system, which will surely modify the values of cells. That I have to do. To do that, I should know theory behind this. For that, let there be n bus system. There are n buses. Between reference and J, I add a element with ZB information. How this will create me tentatively a row, a column. Later, this is deleted off. How to do it? Let's take, in this case, an old bus J is connected to the reference bus R, and an impedance between these two buses is ZB, as shown in the diagram. Referring to bus K, whatever I have here, okay, connected to the reference bus, then definitely Vk is 0. So you should refer this as K 0. Now, if is connected to the reference bus, Vk is 0. You can just see. I mean, this one. This is connected to 0. This bus, I tap one wire to ground. The meaning of this. Draw one line from K to ground. There was a K here. K is driven to ground. Now K is dissolved in R. This become a line. Are you getting my point? This line, Kth bus. Kth bus, I make a short with the ground. It become K become R at the end. This is what is the diagram. So bus K is connected to reference bus R. Therefore Vk is 0. You are tying Kth bus to reference means voltage of K become 0, reference voltage. Then V1, V2, V3, different voltages what I can see. Kth bus voltage go 0. Then old bus what I had here. I mean, what the values of Z1, J1, J2, whatever I got here. These were in the row, column extra. I just write them. Are you able to see? ZJ1, ZJ2, ZJN, and reflect them in the column ZJJ plus ZB. Just see. Tentatively, you will be getting what is this ZJJ, what is this ZJ1. Initially, it happens. Over a problem, you will get a confidence what I am doing. It means the elements what I calculate concerned to build a potential at bus K from jth bus due to element 1, bus 1 current, due to 2, bus 2 current, superposition. These elements need to be removed at the end. How to remove them? To remove them, I should see. From this equation, last equation, if you separate 0 equal to ZJ1 I1 plus ZJ2 I2. If I split and write it, are you sure? What is IK from this? IK is heading if I want. Rest all these terms, put other side. It become -1 whole equation divided by ZJJ, ZB. You can see. I make last equation in this matrix form separated. Then I make equation heading as IK. Expression of voltage for ith bus. Suppose in this, any voltage in the ith bus. How we can write it? Voltage due to ith bus or because of all the 1 to n buses is Vi equal to Z I1 I1, Z I2 I2 plus so-called last term Z I J I K. This is usual. This you can see here. There is no doubt about it. We can just see what is VP here. VP is Z P1 I1. VP is plus Z P2 I2, PP IP, PQ IQ, like that. These terms are with this term 1, 2, 3 space with the currents. Same thing I am trying to convey here. It is Vi, voltage at any bus I here is Zi1 I1 plus Zi2 I2 plus Zi3 so called Zin plus this extra term. What is extra term? Zij into Ik. This is the voltage at any bus I. From this, suppose Vi, how I can write this? Using Ik equation. Ik, I can write Zi1, see here, minus Zij J1 is this I1, this I2, this I3. I am trying to write what is this cell Zi1, Zi2, Zi3 or Zin getting modified when I delete this row, delete this column. I have to delete it because when I have a type 3 modification, there is no extension of the bus number. But here I got one row extra, one cell extra here, which I want to delete here. If I want to delete this row I have to delete, this column I have to delete, this K I have to delete. I have to inject this entire row or delete this. Simply I cannot delete this from this picture. When I want to remove this, effect of this on the remaining cell I have to pass. That's what I am trying to do. Suppose bus voltage Vi is of general voltage like this. When I delete this row and column, what will be the effect of deletion of this? That is, elements of old Z bus are getting modified. I am trying to tell you all these cells get modified. In fact, I am telling you any bus say I, effect of removal of a row and column is Vi in general is like this. Now Zi1, Zi2 are the elements. These will not remain Zi1, Zi2. Then what will be the revised value of that? Revised value of them is Zi1 old. You can see minus Zij, Zji divided by Zjj plus Zb. This is called differential term removed from this value to compensate removal of this row and column from each cell values. Like the voltage of ith bus after removal of this row and column is getting modification through cell or values of Zi1, Zi2 like that. Like Zi1 revised, say new is Zi1 old. What is old? Old minus the differential of this. This differential is coming from this value minus Zj1 divided by Jj Zb plus what is Zi2? Zi2 old minus Zij Zj2 divided by Jj plus Zb. What exactly I am doing here? If I want to tell in literal, it's very simple. It's very simple. For any voltage of a bus, Vi, Vk, V2 like that, you go to respect to column, this column, the value of this Z you want to modify, old value like this, write old value, minus the column's extreme end, what do you have here? J1 into its cell's extreme value, what is there? 1J, multiply these two corners, you can see Ij, J1. So this cell you are trying to modify, write the old value, then come to the extreme edge of the column, write this, extreme edge of the row, product of this, divided by this corner element. You can see it, same thing. Zi1 is say somewhere in the ith row value, Zi1, right? Zi1 minus its end. What is the end of this? J1. I wrote here J1. And its extreme edge, you have Ij divided by corner element. For the next element, suppose J2, this column, second column you want to do. Second column value, whatever is the value available here, old value, that is old, right? Old value. Minus its extreme edge in the column, J2. You can see J2. Product with its row last value, which is Ij, divided by corner diagonal. Likewise, all the rows, all the columns, you have to tamper, modify. After modification, delete this row, delete this column. That is the work in type 3. Why we are doing it now? You understand the logic. We are trying to connect a line between any existing bus with a reference, as if we took it K as a arbitrary branch element. We know that when it is considered as a new bus, one row, one column comes extra, but K is no more K is reference. When I take this row, column, I have to delete, which is not in the picture. It is only for theory. Once it is not in the picture, deletion of them is reflecting them with the new values. When I have a new values here, these are the new values of cell. This can be written as Z bus new. This was an old Z bus. These are the new values added to this. Delete this, become Z bus new. It is called Z bus new is Z bus old minus diagonal. What is the diagonal? ZB plus ZJJ into this column, into this row. You can see here. This is cut and paste here. Cut and paste here. All this value. Z1, J2, ZNJ. ZJ1 to ZJN. Column, row. Whatever I am speaking here is the same thing in the matrix form. This is type 3. When I add link from reference to existing bus. The same thing may happen in type 4. It's very simple. I may add between any old to old, a ZB branch. Old to old. So no new bus extra. For this again I have what is ith bus voltage in general, Zi1, I1, Z1, I2, like that. When I connect a branch between I and J, you can see current flowing here, suppose it is IK. I plus IK will rush here. From this Ij minus Ik will remain, will go here. K will come back on this line. With this, if I write the equation, what is the voltage of I? What is the voltage of J? I can write these two equations like our conventional equations. So, Vj equal to voltage at this bus is equal to Zb into Ik plus Vi. Vi voltage plus this drop. If I add, that becomes J voltage here. Vi if I know, drop if I know, Ik into Zb, I can write Vj. Then what is Vi? Vi is general equation like this. And taking these two equations, simplifying them, as I said, there will be one row, one column extra like earlier. One row, one column extra. This is no more required because in the link addition, there is no physical extra bus created. This is between the existing buses only. Then temporarily created bus number K. Whatever the K I had, K what I am doing here. In this case, K I am connecting to ground. I made it to 0 here. Now K I am connecting to I this time in this case. Can you see here? K, instead of connecting to reference, I hook it to I. K become I for me now. So therefore, this is hooked to I. K is no more in the picture. Then again I have bus K voltage 0. Then whatever the values I have between I and J, I have to mention. I have to delete this. Deletion is what? Same process. Deletion of this new row and column. How I did it? Old value minus product of row edge and column edge divided by diagonal. The same thing I am doing. This into this divided by diagonal. You can see Z bus old minus 1 divided by terms like this. So this we need to see once. This equation we need to remember.